Welcome back, quadrature fans. Today we will continue with our invariant and our quadrature series. And our job today is to estimate what the area ratio K2, which is the ratio of this wedge to the box, and C2, which is the slope ratio of this slope to this diagonal. Just ballpark estimates. It's not super accurate, but estimates are important. It has to make common sense. And it's always good to have estimates. As an engineer, you use this all the time, this ability to estimate. That's a good thing. So let's get to it. What's the area ratio? What do you think is the area ratio? And well, we can look at kind of there are two bounds. You can see this would be kind of the large side. It's not 1/2. 1/2 would be, because this goes from 0 to 1, 0 to 1. It's a y equals x squared. And so definitely it can't be 1/2. It has to be something less than 1/2. We can see that. Less than this. This would be the upper bound. And then similarly, if you do the tangent, somewhere around here is the tangent. Well, that's the lower bound. If you do the area of this wedge, see this? That's kind of the lower bound. So it's something in the middle. So what do you think that is? Tell me where you think I should stop as I'm doing this. I would say
Right there.
right there. Okay. That's actually a very good estimate. Very good. Let's see what this is. So I got this. Well, let's just mark it. Ready. So we said it's from there to there. So it's this wedge, this triangle that you see right here. Maybe I should even draw it. Why not? Something like that, okay? So we drew it. So let's estimate what this area is. I mean, no problem, eh? I'm using really crude tools. And here's a piece of rope. And so 1/2. Okay. So 1, 2, 3. This looks like 2/3, and this looks like about 1/3. That's a pretty interesting estimate, yeah. So what would be the area of this triangle? Well, the area would be 1/2 of base, which is 2/3 times the height, which is 1. Well, look, equals 1/3. So our estimate is that this thing's 1/3, pretty close. I mean, you estimated it yourself. Not bad. Okay. So C2, which is the area of this wedge compared to the area of the box. We're talking this area here. Let's just draw it. Okay. That area to the area of the box. That's K2. Well, that area here we estimated as, what was it? 1/3. And I shouldn't say equal. Well, this equals, we said about 1/3 to 1, right? So this whole thing is equal to 1/3. Just by looking at it. That's pretty good. I mean, yeah, you can kind of see that if you move too much, no, too little, just right. That's kind of the Goldilocks principle. You know, not too much, not too little, but just right. Yeah, Goldilocks was, she was a mathematician of sorts. Okay. Let's estimate the value of C2. Now, where's my little white bee that I had? Oh, it's gone. Have a white bee, please. Thank you. Yes. What do you think is the value of C2, which is the... Basically, we need to know what this is.
1/4.
Is that about right? Yeah. Because that's not right. I mean, yeah. We're looking at the tangent. And that's about it, right? So we can see that's about 1/2 to 1. This tangent from over here, it's getting cluttered, but the slope of this, I mean, look, compared to the slope of this diagonal, the slope of this diagonal is 1 rise over 1 run. It's just 1. And the slope of this, well, it looks like it's twice, right? You've got the same rise, but over half the run. So C2 equals M tangent over M diagonal, right? And this we estimate as 1/2 over 1. And that equals 1/2. So, just from simply looking at this, we have arrived at values of K2 and C2. This is K2. Here's C2, our slope ratio. And we've determined that, yeah, roughly K2 is about 1/3. And C2, our tangent ratio, is about, no, not 1/2, it's about twice, sorry. I made a mistake. Let's go back, fix it. Aha! I got rise over run. Okay, what's rise over run? So 1 over 1/2. That's a problem. So that equals about twice, right? It's steeper. This thing's steeper than this. If this is 1, this is 2. Okay. So we've got K2, we got C2, 2 invariants. Iso ratiometric invariants. They are the same by rubber band geometry. This applies to anywhere. If you draw the box right here and do the similar things just within this box, you'll come to the same results. It will be, you'll get an estimate for K2 and C2. So, okay. All right, let's cut it here.